This is SpaceTime, Series 24, Episode 37. Coming up on SpaceTime, Earth's first supercontinent, getting ready for the first helicopter flight on Mars, and Virgin Galactic unveils its latest spaceship. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggested Pangea was simply the latest of about 3 supercontinents which formed on the Earth's surface, and that they all formed within the last 2 billion years. The findings, reported in the journal Geology, mean the planet's early convection and tectonic activity didn't allow supercontinents to form during the planet's first 2.6 billion years of existence. The study's lead author, Dr. Yibo Liu from Curtin University, says his findings suggest that plate tectonics operated differently before 2 billion years ago, and that the 600 million year supercontinental cycle only started during the second half of Earth's life. If Liu's correct, it means the shift in plate tectonics marked a regime change in Earth's system. And this regime change impacted on the eventual emergence of complex life, and even how Earth's resources are formed and preserved. Pangea was the first supercontinent scientists discovered early last century. It existed some 300 million years ago, lasting until the age of the dinosaurs. Since then, ongoing tectonic plate movements caused by convection split Pangea up, eventually forming the continental pattern we see today. Recently, geologists including Liu determined that at least 2 other supercontinents existed prior to Pangea, forming and breaking up again over the past 2 billion years in roughly 600 million year cycles. But what happened during the first 2.5 billion years of planet Earth's history remains a mystery. The research by Liu and colleagues tested 2 hypotheses. One is that the supercontinent cycle started prior to 2 billion years ago. Alternatively, the ancient continents, known as cratons, only managed to get together in multiple clusters known as supercratons, instead of forming a singular supercontinent. The authors carried out their study by venturing into the hills east of Perth, to an area known as the Yilgarn Craton. The Yilgarn Craton is a massive object, constituting the bulk of the Western Australian landmass. The region is bounded by a mixture of sedimentary basins and Proterozoic fold and thrust belts. And it's ancient, with zircon grains in the craton's famous Jack Hills area having been dated to between 4.27 and 4.4 billion years ago. That makes them some of the oldest crust on Earth. Yilgarn is a critical piece of the puzzle, not only because it's old, but also because there are a series of dark rocks or dolerite dikes that recorded Earth's ancient magnetic field at the time when the rocks first solidified. By precisely dating the rocks and measuring the sample's magnetic record using a technique called paleomagnetism, the authors were able to reconstruct where those rocks were relative to the magnetic North Pole when they formed. By analysing the new data from Yilgarn and then comparing it with data available globally from other cratons, the authors were able to rule out the existence of a long-lived single supercontinent before 2 billion years ago, although transient supercontinents may well have existed. More likely, there have been 2 long-lived clusters of cratons or supercratons before 2 billion years that were geographically isolated from each other, never forming a single supercontinent. This research goes some way towards solving a long-standing mystery. The idea of even older supercontinents have been speculated about for years. But while it's been difficult to prove, it's also been just as difficult to disprove. Now, Liu admits this study isn't the final word in the debate, but it's a step in the right direction, and more data needs to be collected from lots more similar rocks in order to further test the hypothesis.
The target we studied is some dark rock called dolerite, and we basically sampled this dolerite in 150 kilometers east of Perth, and through radiogenic dating and some detailed magnetic experiments, we are able to date these rocks to their time of formation, and we are able to determine the magnetic directions logged in them when they are formed. And with this information, we compare our data with other data available globally. So we find that in Archean to Proterozoic transition, which is about 2.6 to 2.4 billion years ago, there was no supercontinent as we know it afterwards. So a classic supercontinent is Pangea, which basically compose most of the continents of the world today. And after Pangea breakup, the world has become the way it looks today, and we are basically on our way to form the next supercontinent. From 2 billion years ago to present, it's generally accepted there were at least 3 supercontinents. So the appearance of a supercontinent changed so many things. It changed, it may be infected greatly that the appearance of complex life. It affected how the whole mantle convex, and it affected how the whole Earth engine works. So we already know that it's generally accepted there were roughly 3 supercontinents existed during the past 2 billion years, and each of them, from the assembly, duration, and breakup, each of them existed about 500 to 700 million years. But before 2 billion years, we didn't know what it was like. There could be another supercontinent, but we didn't know. And with our new data and our new model, we suggest that the likelihood a supercontinent existed before 2GA is very slim.
Why was the Earth different more than 2 billion years ago? What do you think it was? There was still a magnetic record there, but it was difficult to arrange the cratons in such a way that they would have formed a supercontinent.
Yeah.
What do you think was different about the Earth back then that resulted in that? Was it just too hot, or too much turbulence, or in the mantle?
Yeah, good, very likely. So before 2GA, the convection pattern of the mantle could have been just very chaotic, and the whole mantle convection hasn't started yet. So it's difficult for all the continents to fall to the same location to form a large supercontinent. And maybe through the secular cooling, at one point, all these small shortwave mantle convection arranged together to form a long wavelength mantle convective pattern and form the very large scale super downwelling, which dragged all the continents to one point of the Earth to form a large continent. So something happened, you could say something happened before, after 2GA.
So it's that there wasn't enough convection going on in the mantle at that time. Is that what we're saying?
It's the convection pattern.
The convection pattern was different.
Yeah, it was not as organized as like after 2GA.
That's Dr. Yibo Liu from Curtin University. And this is SpaceTime. I'm Stuart Gary. Still to come, NASA getting ready for the first helicopter flight on another world. And Virgin Galactic unveils its new SpaceShip III. All that and more still to come on SpaceTime. NASA Mars 2020 mission managers say their Ingenuity helicopter should be ready for its maiden flight on the Red Planet in the next few days. The 1.8 kilogram rotorcraft had been attached to the belly of NASA's Perseverance rover, which touched down on the Martian surface in Jezero Crater back on February the 18th. On March the 21st, Ingenuity was uncocooned from its guitar-shaped composite carbon fibre graphite debris shield, which had protected it during the landing. The tiny helicopter is now undergoing a long series of checks, with NASA targeting no earlier than April 8th for the historic first flight on another planet. Once deployed, Ingenuity will have 30 Martian days or sols to conduct its test flight campaign. But flying in a controlled manner on Mars is far more difficult than on Earth. The Red Planet might only have a third of Earth's gravity, but its atmosphere is just 1% as dense as that of the Earth. So there's far less air for Ingenuity's rotor blades to grab hold of. And the problems don't end there. During the Martian daytime, the planet's surface receives only about half the amount of solar energy that reaches the Earth during daylight. And at nighttime, temperatures on Mars can drop to as low as minus 90 degrees Celsius, cold enough to freeze and crack unprotected electrical components. To fit within the available accommodations provided by the Perseverance rover, the Ingenuity helicopter had to be small. To fly in the Martian environment meant it also had to be extremely lightweight. Yet to survive the frigid Martian nights meant it had to have enough energy to power internal heaters. The entire system, from the performance of its rotors in the rarefied Martian air through to its solar panels, electrical heaters and other components, were all tested and retested in vacuum chambers and test labs at NASA's Jet Propulsion Laboratory in Pasadena, California. But testing them on Earth is one thing. How they perform in the real-world conditions following launch, the 7-month journey to the Red Planet, and the descent down to the Martian surface is quite another. Ingenuity's first flight will be from a 10 by 10 metre patch of Martian real estate chosen for its flatness and lack of obstructions. Once the helicopter and rover teams both confirmed that Perseverance was situated exactly where they needed it to be, the little chopper was slowly deployed onto the surface over 6 Martian days, and then the rover was moved clear. Next, Ingenuity will run its rotors at 2,537 revolutions per minute, and if all final pre-flight checks look good, lift off. After climbing at a rate of about a metre per second, the little rotocopter will hover about 3 metres above the surface for up to 30 seconds. It'll then descend and touch back down on the Martian surface, completing its first historic flight. If all goes well, there'll be lots more flights following the first one, but that first flight is the one everybody's waiting for.
We use drones and helicopters here on Earth for all sorts of things that they're more suitable for than land-based vehicles, right? So you can just imagine being able to have that same capability on Mars, flying around on Mars. And that could be for reconnaissance purposes, taking pictures to scout out areas, potential science targets for future rovers or even future astronauts.
As part of the historical event, Ingenuity's carrying a bit of history, a small sample of material from Orville and Wilbur Wright's Flyer. The Wright Flyer, of course, undertook the first ever powered controlled flight on Earth near Kitty Hawk, North Carolina, back on December the 17th, 1903. The Apollo 11 crew also carried a piece of material along with a small splinter of wood from the Wright Flyer to the Moon and back during their iconic mission back in July 1969. This is SpaceTime. Still to come, Virgin Galactic unveils its first SpaceShip III, and the world sits up and pays notice when the US Strategic Command, which controls America's nuclear missile arsenal, issues a strange cryptic tweet. All that and more still to come on SpaceTime. Virgin Galactic has rolled out its newest spacecraft, the first so-called SpaceShip III variant, officially named VSS Imagine. The new vehicle features upgrades to improve maintenance access and flight rate, but its most stunning feature is its new silver finish, which is said to be a key part of the ship's thermal protection system, as Virgin Galactic boss Sir Richard Branson explains.
The unveil of our new beautiful spaceship marks the expansion of the fleet. With this being the first spaceship of the Virgin Galactic SpaceShip III class of vehicle. Our hope for all those who travel on this spaceship is that it will offer new horizons, fresh perspectives, and spark ideas that will bring positive change to our beautiful planet. That's why we are calling our new spaceship VSS Imagine. Our new spaceship's stunning chrome effect livery is a fascinating example of form, function, and thoughtfulness working in perfect harmony. Our engineers originally specified that a reflective material was needed on certain parts of the spaceship to protect it from the heat of the rocket motor. Well, we love the look of it so much that when we built Spaceship Unity, we used more of the chrome than strictly necessary, but to great visual effect. We noticed that the spaceship became at one with its natural environment by reflecting it, whether on the ground, in the air, or in space. I can't wait to see Imagine flying. The spaceship is going to start ground testing first, and then it will start with its test flight program in the summer. Having both Unity and Imagine up in the skies will be an exciting time for us all.
The VSS Imagine SpaceShip III follows on from the VSS Unity SpaceShip II vehicle. which itself was an expanded, upgraded version of Burt Rutan's original scaled composite SpaceShip I, which won the X Prize in 2004 after being the first privately operated manned spacecraft to reach space twice within 2 weeks. The new spacecraft will begin glide flight testing around the middle of the year. That should coincide with Unity's final round of testing, when it will again try to reach the Kármán line of 100 kilometres or 328,000 feet, the internationally recognised official start of space. So far, Unity's only reached the lower altitude American definition of space, which is 80 kilometres. Meanwhile, Virgin Galactic's main competitor Blue Origin has already launched its new Shepard rocket and capsule on 11 test flights beyond the Kármán line. They ought to be carrying their first paying space tourism passengers by the end of this year. Virgin Galactic says it now expects to begin carrying paying space tourists on suborbital flights next year. It's also working on another SpaceShip III, which will be named VSS Inspire. Once operational, each Virgin Galactic flight will include up to 6 space tourists paying $250,000 each. The Virgin Galactic flight profile sees the spaceplane mounted under the center spar wing section of a White Knight II mothership, taking off horizontally on a conventional runway. That's different from Blue Origin, which launches vertically from a conventional gantry like a traditional rocket. The twin fuselage 4-jet engine-powered White Knight II mothership will climb to an altitude of about 15.5 kilometres, roughly 50,000 feet, where it will drop-launch the spacecraft, which will then fire up its single hybrid rocket engine for a 70-second burn, accelerating it to over 4,000 kilometres per hour, more than Mach 3. After main engine cutout or MECO, the spacecraft will continue to coast on a ballistic trajectory to an apex of 110 kilometres, 361,000 feet. There, passengers will experience the curvature of the Earth, the blackness of space, and the thin blue line of Earth's life-giving atmosphere. They'll also get to experience a few minutes of weightlessness. As it plummets through the atmosphere, the twin tail booms will be raised into a vertical feathered position to increase drag, thereby helping to slow down the rate of descent. At an altitude of 22.9 kilometres or 70,000 feet, the tail booms will be de-feathered back into a horizontal configuration, allowing the spacecraft to glide to a conventional runway landing. By comparison, New Shepard's passenger-carrying capsule will float back down to Earth using parachutes, while the booster stage undertakes a separate powered vertical landing. Virgin Galactic's development suffered a major setback back in 2014 when the VSS Unity's predecessor, the VSS Enterprise, broke apart in mid-air, killing one of the test pilots after he released the feathering system during the ascent to space. Releasing the feathering system during ascent allowed it to lock into place, forcing a huge aerodynamic load on the airframe, causing the spacecraft to break apart in mid-flight. This is SpaceTime. Still to come. A cryptic tweet from the US Strategic Command sends the world into a buzz, and later in the science report, researchers discover a new type of immune system T-cell. All that and more still to come on SpaceTime. Often described as the toilet door of social media, Twitter looked like things were getting a lot more serious the other day when the official Twitter account of the United States Strategic Command, which runs the nation's powerful nuclear weapons arsenal, suddenly tweeted what looked like a cryptic code. The message simply read, semicolon, the letter L, followed by 2 more semicolons, followed by the letters GML, XCS, SAW. Now, because it is the US Strategic Command or STRATCOM, any communications by that organisation are closely monitored and carefully evaluated. And as you'd expect, this tweet got serious attention all over the world. There was one tweet saying it must be the US nuclear launch code. Another tweeted the Pentagon must have been hacked. But surely the best tweet was a response simply saying, confirmed launches go. Was World War III about to begin? Well, as we're all still here, the answer was clearly no. As it turns out, Stratcom's social media editor was working from home and momentarily left the command's Twitter account open and the keyboard unattended. And of course, that's something you never do if you've got a cat, or in this case, a young toddler. 30 minutes later, Stratcom tweeted to disregard the previous tweet. But by that time, the memes had begun spreading. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists have discovered a new type of immune system T-cell. T-cells are specialized cells that play a fundamental role in protecting against infections by using molecular sensors called T-cell receptors to detect and eliminate invading pathogens. Until now, scientists thought there were only two types of T-cells characterized by their receptors. But a report in the journal Science claims researchers using the Australian synchrotron at Monash University identified a novel third type of T-cell which is found only in marsupials and monotremes. Scientists say the new discovery has the potential to expand the immunology toolbox. Russia's Weather Monitoring Institute Rosgidromet has released new data showing the Russian Arctic saw record-high average temperatures and an historic decline in summer ice coverage during 2020. The agency says Russia's average annual temperature last year was 3.22 degrees Celsius higher than the average for the entire period from 1961 to 1990, and more than a degree higher than the country's previous record in 2007. The data confirms that Russia's increase in warming is much higher than the global average, and the Arctic Maritime Northern Sea shipping route is now almost completely ice-free by the end of summer. In fact, ice cover is now 5 to 7 times thinner than what it was back in the 1980s, with 2020 surface ice cover reaching a record low maximum extent of just 26,000 square kilometres in September. Scientists have discovered a new way to dramatically increase the power storage capacity of lithium-ion batteries. Lithium ions have become almost ubiquitous in everything from portable electronic devices to electric cars, and researchers around the world are working feverishly to try and achieve even higher energy densities in them. That is, the amount of energy that can be stored in a given mass of material. Increasing energy density increases both the performance of existing devices and the time between charges. Now, a report in the journal Nature Energy claims scientists with MIT have discovered a new metal electrode that can replace conventional graphite electrodes, allowing lithium-ion batteries to have higher charge voltage in the cathode. Previous efforts failed because they caused a variety of unwanted chemical reactions to take place in the electrolyte separating the electrodes. Researchers say their new metal electrode overcomes these issues without sacrificing cycle life. It means lithium-ion batteries, which now typically store around 260 watt-hours per kilogram, should be able to hold 420 watt-hours per kilogram, a massive increase that will translate into a longer range for electric cars and longer-lasting charges on portable electronic devices. Paleontologists have uncovered the remains of an extinct species of tree-climbing kangaroo in the Thylacoleo caves on the Western Australian Nullarbor Plain. The discovery, reported in the Journal of the Royal Society Open Science, claims Kangaroos kitcheneri lived in Australia between 2.6 million and 12,000 years ago. Kangaroos and their relatives descended from arboreal possum-like ancestors during the Paleogene period before becoming the main ground-dwelling mammalian herbivores on the Australian continent over the past 20 million years. Today, there are more than 60 living species of bettongs, wallabies and kangaroos. They use a bipedal hopping mode when moving at speed, but resort to an unusual pentapedal mode which uses the tail as a fifth limb when moving slowly. But one living genus which deviates from this pattern is Dendrolagus, which contains the tree kangaroos of northeastern Australia and New Guinea. They are descended from ground-dwelling ancestors by ascending back into the trees. The Thylacoleo cave fossils include 2 cranial specimens and 2 near-complete kangaroo skeletons, a male and a female. In Star Trek, Q are a species of omnipotent and immortal non-corporeal entities from the Q continuum. The name Q was then usurped by an anonymous keyboard warrior in October 2017 who began posting amazing claims and conspiracy theories or Q drops claiming to have a level of US security approval known as Q clearance. The claims being made were so fantastic and they fitted in with such an interesting narrative that it attracted a lot of attention from a significant section of social media. While it began as an American phenomenon, Australia has now also become fertile ground for what's now referred to as QAnon. In fact, Australians have proven to be highly capable of adapting international conspiracy theories like QAnon to the local context. And the issue isn't going away. Tim Mendham from Australian Skeptics says, latest reports show that Australia is now the fourth largest country for QAnon activity behind the United States, the UK and Canada.
Okay. It's a long history of sovereign citizen movements, which is basically people saying government should have no control over me at all. Governments do not have the right to make decisions that impact on me. I don't agree to them, right? If I don't agree to the government, I don't have to agree to their regulations. And a lot of that comes down to traffic infringement in the real world. But sovereign citizens is this area we've covered in the Skeptic magazine. The QAnon movement has been around, it's been around a few years, not a huge number of years, but this sort of person of unknown who he is or who they are, really, supposedly from someone within government, within sort of public sector or something like that, who knows the truth, spreading out these messages and then just builds up from there. It builds up beyond Q.
It's like the X-Files Cancer Man, isn't it?
Yeah, it is strange. It just builds up and up. And the suggestion is it's very strong in America. There's a lot of followers go around with their big Qs on their T-shirts and that sort of thing, the letter Q. And it's very strong in America and it's infiltrating into other countries. And the suggestion that one particular article that came up recently is that it's growing in Australia. But it's growing as a mirror of the American experience. So a lot of the things that people in Australia are complaining about are American situations, like Trump not having lost the election, right? And you think, you're in Australia, you're not in America, you're really concerned about this as a pressing issue, or that sovereign citizens claiming some sort of amendment in Australia to defend themselves. Well, we don't have those amendments in Australia. We don't have the American Constitution in Australia. But yet a lot of these conspiracy theorists, sovereign citizens, Karens, and QAnon followers are quoting American experiences. Now, there's a survey done of how strong, based on Twitter posts, as to how strong they are in various countries. Australia falls fourth in this particular list after the US, UK, Canada, Australia, and then Germany. But the thing is, UK, Canada, Australia are way below, way below the activity that's in the US, and not just on a per capita basis, on every basis. So, there's a lot of suggestion that QAnon is strong here, and certainly there are some QAnon followers and people quoting QAnon theories without mentioning QAnon in our parliaments, really, now, but they're fringe, by and large.
But how has Australia become such fertile ground for this misinformation?
I really don't know. It just has in a way, but perhaps it's sort of the publicity that they're getting in America and it's people are just sort of following, they think they're following American politics and American political theories. And even so, the issue is that it's not being pointed out that it's a ridiculous sort of thing, we'll ignore it. Well, that means it builds up. But it's still small in Australia. It's not huge by any means. But things like the COVID outbreaks and 5G are all classic QAnon conspiracy theories. And because we have the same situations here with COVID, or at least we have the virus here, even if it's not having the same numbers, and we certainly have 5G here, is that people are just picking up on these theories willy-nilly without any great research, which is good for QAnon, because if you did any research, you realise it's rubbish. And you get a few, politicians who are people. There was one senator who tried to submit a list of prominent Australians. He said we're all pedophiles, and this thing about child sex abuse, child eating, and all these things is just classic QAnon. And it's just so there's a few politicians who actually just re-quote them, and then it builds up. But I think a lot of it is. The impression that a huge movement is misguided at this stage. I don't think they necessarily are as active as a lot of the media would make them out to be. They're certainly loud in the same way as the anti-vaxxers are loud, but sort of how serious an issue is, I don't know.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTimeWithStuartGary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.